All right, so for problem number 1, what should be the diameter of a circle wire loop if it is to have a magnetic field of 0.15 Tesla oriented perpendicular to its area, which produces a magnetic flux of 1.2 times 10 to the negative 2 Tesla meters squared. So let's start listing some of the things that we know. So really, the formula for magnetic flux is going to be the magnetic field times the cross-sectional area times cosine of theta. And so we know that the magnetic field is 0.15 Tesla. We know that the flux is 1.2 times 10 to the negative 2 Tesla meters squared. Okay? And then they want to know the area, right? Is that the question?
The diameter.
Yeah. So it says what should be the diameter of the circular wire. Okay? And so now here's the weird thing. So now the area, when they say circular, the area of a circle is pi r squared. But since we're solving for the diameter, we want to write that in terms of the diameter. So the radius is really what? Half the diameter. So we're going to say d over 2 squared. So then the area is equal to pi squared, or pi times d squared all over 4, because we square the numerator and the denominator, right? And 2 squared is 4. Oh, that looks bad. Okay. And so let's plug in what we have, and then I think we have enough stuff. Oh, one other thing is, what is the angle? Theta is actually 0 in this case. 0 degrees. Okay? And so I think if we plug everything in, we have nothing but numbers and the variable d. So this is going to be 1.2 times 10 to the negative 2 is equal to 0.15 times pi d squared all over 4 times cosine of 0 degrees. Okay? And so let's well, yeah, so we got to multiply. Let's multiply everything by 4. So I'm going to say 1.2, whoops, 1.2 to the negative 2 times 4. I didn't need to do that, but I'm just showing you. That's 0.048. So let's write that down. So if I multiply both sides by 4, okay, then this will cancel. And I get 0.048. And I'm rewriting it, right? We could do that because of the commutative law. All these numbers, this is multiplied by this, is multiplied by this, is multiplied by this. So I could reorder everything using the commutative property of multiplication. So now I just need to divide by 0.15 pi cosine of 0 degrees on both sides. 0.15 times pi times cosine of 0 degrees. And I'm going to make sure that I'm in degree mode, although it doesn't matter. 0 radians is the same as 0 degrees, but I'm going to just make sure I am in degree mode. And so I'm going to take that number and I'm going to divide that by, in parentheses, 0.15 times pi times, cosine of 0 degrees. Is that right? Did I miss anything? All right. And I think if I hit enter, I get 1.1. Okay. So now let's plug this in.
That's 0.1.
It's 0.1.
What's that?
0.1.
1.0185. So let's just do.
No, it's 0.101.
Am I saying it wrong?
You're
Yeah.
saying
Okay.
1 point.
All right. So it's 0.10185 something. We'll say 0.6. We'll round it off. Okay. Is equal to d squared. And so then we take the square root of both sides. So let's do that on our calculator. And we get 0.32. And so that's, if I round that up, it's 0.32. And that's the answer in the back of the book.